In this video, we're going to take a closer look at how this architecture works and how the innovations from NVIDIA and Solidigm are helping solve some of the biggest infrastructure challenges facing AI factories today. Greg, could you tell us a little about yourself and what you do at Solidigm?
Sure. I'm the head of products and marketing for the company. And so I work with customers, ecosystem partners alike to make sure we're defining the right products for all the different parts of the storage market, and then working with our ISVs and our customers to bring those products to market.
So I'm Kevin Deerling. I work for Jensen at NVIDIA. I came in through the Mellanox acquisition, which does networking. And that also means that I connect storage. So I work for the storage to make everything that connects to GPUs super important, that we have great connectivity, high speed, low latency, and flash is a big part of that. So we're excited with SSDs and the storage that AI needs to think.
Thank you both for being here. Let's dive in. What are you guys most looking forward to in 2026? Like, what's changed in the last year and what's exciting?
Yeah, I think 2025 was clearly the year of inferencing, and we saw just a giant pickup in AI. And 2026 is the year of agents and the claw.
Oh, look at that.
The claw. So OpenClaw, Nemo Claw, it's incredible. People don't understand what a revolution this is. It is fantastic with agents talking to agents, consuming more and more tokens. It really is going to transform the way we do our jobs. Really looking forward to 2026.
Yeah, for us, so we're a storage company. And so, the last couple of years, you've seen a lot of growth in your products, right? And it cut kind of towards the end of 2025 and ramping now into 26. For us, it's really the year of memory and storage. And people seeing how pivotal that storage is and how required it is to be able to get the most out of the GPUs and the rest of the AI infrastructure, and produce as much money and tokens per second as you can.
Yeah, what I love about what you said is that it's the year of memory and storage. And that's really important because storage is actually another tier. It's so important. We just don't have enough. And thinking needs more memory and storage. So as we get to agentic workloads, we need to remember things. And you're going to write things down. Open clause. The first thing it does is say, here's a to-do list.
Yep.
And it works from that. And it has things like store and file and vector databases and KV cache. We're really excited about the work we're doing together.
And so are we. And we're innovating on all those different tiers too, right, together. So it's a great partnership.
So Kevin, why is now the right time to add a new storage tier in AI? What does it mean for clusters?
Yeah, it's interesting what's happened with inferencing. It's thinking. And part of what's happening with AI is we're reading a ton of documents. They can be PDFs, they can be diagrams, and it goes through a phase that's called prefill, where you read everything and then it starts to respond. And it creates something that's called KV cache. And it's really interesting. If we save that to storage, we can reuse it. So for example, we're showing here that we can actually read the entire IRS code, 7,200 pages. And then you can ask questions about that. Now, if somebody comes out back and asks us a follow-on question, we have a choice. We can either reread it again, redo all the compute, or we can store it and reload it. And if we do that, we get a great benefit. We get two great benefits. The first is you get answers a lot faster because you didn't have to read all of that and understand it and create the KV cache. We just load it and we start answering questions right away. So faster time to response. The second reason is that we actually get a lot higher throughput from the data center. So we want more tokens. Tokens are a constrained commodity. People want more tokens. And because we've computed it and we've restored it, now we don't need to recompute it. So we can use those GPUs to create more tokens more efficiently from the data center. So you get two great benefits. And so that's why we need this new tier of storage.
Well, you said it pretty well. So, and from what we've seen is exactly the same thing, right? Well, we had direct attached storage, kind of G3 level storage, directly attached in the GPU servers, very high performance, but not super high capacity. And then network attached storage, very, very high capacity, but not as fast. And so you have this layer in the middle, which is now pretty high capacity, pretty high performance. And it's really the only way to be able to extend this context memory, because other memory technologies like HBM or DRAM, I mean, HBM's amazing technology, It costs $10,000 a terabyte, so it's pretty expensive. And Flash is really the way to do it in an affordable and scalable way.
Yeah, and just to add to that, it's interesting, the ethos of storage for 40 years has never lose a byte, no matter what happens. You could have a power failure, components could fail, monkeys could get out of the zoo and unplug all the cables, and you still can't lose a byte. Here, it's interesting. We have the original document. We can always recompute it. So suddenly that DNA of storage says that it has to be highly available, fault tolerant. That all goes away. So we can actually do some optimizations that we can have that really nice tier of new storage that gives us the capacity and the performance that's in between, and it doesn't have to be durable because we can always recompute it. So it's really a fantastic new tier of storage for the age of AI.
From both of your vantage points, what challenges do you see in AI factory deployments, and how do the products from NVIDIA and Solidigm really help alleviate some of those challenges?
Yeah, I think one of the big challenges we see is increasing context windows. So as models get bigger, they're able to actually read and remember more, and those context windows are getting larger and larger. And so as that happens, we actually need to distribute it across more devices, and then we need to store and restore the memory. So if you look at these agentic workflows, you're no longer doing something that is a one-shot inference where you ask it a question and you get an answer. We're now doing multi-step agentic reasoning where it plans, reasons, and acts. And it's actually doing a bunch of work, reading a bunch of documents, summarizing it, storing it, and passing it on to another agent that's going to do more work on that. So the combination of more GPUs that are producing more tokens over longer windows, agentic reasoning over a longer period of time, we just need thinking needs memory, which we don't have enough, and we can put it into storage now. And that really becomes the new efficient, high-performance tier of storage. So we love the fact that we've got a partner that can deliver that kind of storage for us.
Yeah, and I think some of the stuff that we look at a lot is, hey, there's a fixed amount of power and a fixed amount of square feet in every data center. Both of those resources are extremely constrained and finite for any individual AI factory, right? And so how do you get the most out of that factory is you have to have the biggest and most productive GPU footprint that you can have. You want to minimize the footprint and the power spent on other things besides GPUs. And by moving to modern storage systems, away from legacy systems, you can both reduce the power usage as well as the storage footprint by as much as like 9-to-1 ratio, compared to like a hard drive or hybrid-based system.
How have NVIDIA's AI infrastructure roadmap and Solidigm's SSD roadmap influence each other? And what does that look like, that co-design process look like in practice?
When NVIDIA was talking about needing liquid-cooled SSDs, for example, we worked together, brought some thermal innovations that we had been working on kind of as a lab-based project to NVIDIA. They liked the solution. We had to adapt it and make sure that, get the pieces and parts right, both in the SSD, but also in the thermal enclosure that the SSDs go into. But basically, we came together and brought the world's first liquid-cooled SSD and the solution to market at last year's GTC about a year ago. And now with your new context memory storage, we're working on the next generation of those liquid-cooled form factors because it's a different form factor enabling higher capacity and very high performance.
Yeah, one of the things that we've done is we built NVLink 72, where we take a bunch of GPUs and we put them in a rack. And Jensen has said copper where you can. We connect that with copper. And when we do that, we're squeezing them together because the distance that we can travel on copper is shorter than we can over optics. But there's real value in connecting those GPUs with copper. And now we have a thermal challenge. And that's what made us move to liquid cooling. And so it's great if we could have all of the components connected and using liquid cooling with copper. And so this is a great opportunity for the SSDs. We need higher performance, so we get the faster next generation of PCIe, and we get the liquid cooling. We can put it all together, very tightly coupled, connected with copper, liquid cooled. That is the ideal platform.
But doesn't it also save space?
Absolutely.
And enables the SSDs to continue to run very continuously without having to thermal throttle themselves and then slow down the GPU workload and token generation and inference.
Exactly.
So it really works together to bring a sustained level of very high performance.
Yeah, we call this extreme co-design, where we're looking at partners, we're looking at all the things that we're doing, we're looking at thermal, we're looking at power delivery, we're looking at electrical, and then of course all the GPU design, the models, it's the full stack. So we talk about a 5-layer cake. You have to do everything. You know, doing one little component just doesn't work. So that's great that we have partners that we're working together ahead of time. You're anticipating, we're sharing information, and then we can come to market at what we call speed of light.
Yeah.
We deliver something together that really is optimized for the market. It has the right density, it has the right power, the right thermals. All of it needs to come together to build the most efficient AI factories.
If we fast forward, say 3 to 5 years, what will AI factories look like, and what role will companies like Solidigm have in that storage innovation that really will enable that future?
Well, what we've seen working with our customers is there's a variety of sizes of AI factories, megawatt versions, gigawatt versions. The gigawatt versions can use up to like 25 exabytes of flash per gigawatt. And that's kind of the number that we've been modeling, which is truly needed to be the most efficient, power efficient, space efficient data centers that are out there. What I think will happen, though, is the increased reliance on partnerships. And so co-designing, we talked about that a little bit already, but I think it'll be needed more and more because the systems are more and more complex. They're very much higher performance. And, from the hardware put together with NVIDIA and the storage, the SSDs from us, also for us, it extends to the software ISVs. And so to make sure that we're co-designing and helping them have a hardware reference design that makes their ISVs shine.
And then what will this look like for NVIDIA in the future as well?
Yeah, so I think question was AI factories. I think you're going to see giant factories and medium-sized factories and small factories and tiny little factories. There's going to be robots and cars. I think we'll have AI intelligence everywhere, and it's going to need context. Context is really the things that you write down. I mean, when you do a lot of thinking, at least I have to write it down, and then I can remember it. I can take that data. I might share it back from a small factory, a robot, out to, we'll see hybrid communications between all of that. And I also think there'll be a lot of new models where we'll have really good governance, and it'll all be automated so that if you have information that needs to be protected, whether it's healthcare or financial information, all of that. And I think you'll see this all being automated so that we can take advantage of all the breakthroughs. I think we'll continue to see a lot of breakthroughs. I'm really excited about what's going to happen. The market responds well. 3 to 5 years is just about the amount of time that we might see some really interesting breakthroughs on this kind of technology. And when there is so much need for faster memory, denser memory, I'm looking forward to some key innovations. We're going to get to, I don't know what it's going to be. It's going to be tunneling through gate oxides. It's going to be vertical. I have no idea what you're going to invent, but I'm looking forward to it. Jensen says smart people do smart things. And right now we need more flash. We need more context. And so it's good to see that you're responding, your engineers are responding. I'm looking forward to great innovations.
And we're racing to keep up.
There you go.
As AI continues to evolve, it's clear that building powerful GPU clusters is only part of the equation. The real challenge is creating the data infrastructure that can keep those systems operating at full speed. AI factories depend on a seamless pipeline between compute, networking, and storage, and that's where collaboration across the entire ecosystem becomes critical. What we're seeing from NVIDIA and Solidigm is a shared vision for how that pipeline should be built, with innovations across the storage hierarchy that help ensure that GPUs stay fed with data and AI systems can scale efficiently. It's this kind of coordinated innovation that will enable next generations of AI infrastructure.